Hey y'all, welcome back. On tonight's homework, we are going to work out problems involving the fundamental theorem of calculus, both parts 1 and part 2. This will just be a kind of an overview of the entirety of the theorem. So let's just start with number 1. It says determine the definite integral of x cubed plus 4 dx from 1 to 2. So here we're going to use the second part of the fundamental theorem, which ironically we covered first. First, we need to find the family of antiderivatives of x cubed plus 4. So the antiderivatives would be x to the 4th divided by 4 plus 4x, and we're going to evaluate that from 1 to 2. And well, you know what? Let me go ahead and put the plus c, just so we don't forget about that. So we'll start by plugging in 2. 2 to the 4th power, let's see, 2, 4, 8, 16. 16 divided by 4 would be 4. 2 times 4 is 8. And we do know those c's are going to cancel out, so I'm not going to bother with it on the second step. And then when I plug in 1, I'm going to get 1/4 plus 4. And so it looks like I have 4 minus 4. So that's just going to be 0. That's going to cancel out. So I just have 8 minus 1/4 left over. So that's going to be 7 3/4. Oh, there we go. Number 2, what is the average value, and that's something we went over in the last lesson, not this lesson, but the last one, of this function on the closed interval 2 to 5. So the average value is computed by first finding the integral of that function from 2 to 5, and then taking that integral and dividing it by the length of the interval. So in this case, over 5 minus 2. So this is our setup. I'm just going to call it f average for the average of f. So let's go ahead and evaluate that antiderivative from the numerator. So that's going to be, let's see here, x cubed divided by, okay, so that's just going to be x cubed plus x plus c from 2 to 5 all over 3. Kind of needed a little bit more room here, I think. So plugging in 5. Ooh, 5 cubed. What in the world's 5 cubed? So 5 times 5 is 25, times 5 is 125. So we have 125 plus 5 minus, and if I plug in 2, I'm going to get 2 cubed is 8, plus 2, and all that divided by 3. So let's see if we could do this. 125 plus 5 is going to be 130. Minus 10 is 120. So this works out actually really nicely. 120 divided by 3 is 40. So that's the average value of f between x equals 2 and x equals 5. On number 3, we are going to use, again, that second part of the fundamental theorem and substitute x and 1 into this function, or not into that function, rather, but into the antiderivatives. So let's see here. That'd be t to the 4th times 1/4 minus 2 divided by 2 is just going to be 1, so just minus t. And then we have a plus c. And we're going from 1 to x. So I need to substitute first x, and then I'll substitute in 1, and then I'll subtract those two expressions. So we've got 1/4 times x to the 4th minus x. The c minus c is going to cancel out. Minus, let's see, 1/4 minus 1. So we've got 1/4 x to the 4th minus, wait a minute, hold up. This should actually be t squared. Whew, almost got that one wrong there. Okay, minus t squared, or x squared. And then we have minus 1/4 minus 1 would be negative 3/4. So minus negative 3/4 should be positive 3/4. Number 4, we've got a function defined as the integral from 0 to x, sine t dt. We want to know what is f of pi. So what we need to do is substitute in pi for x. So from 0 to pi, sine t dt. We first need to find the antiderivatives of sine t. And since the derivative of cosine is negative sine, the antiderivative of sine is negative cosine. So negative cosine t plus c. And we'll go from 0 to pi. So this will be negative cosine of pi minus negative cosine of 0. Well, cosine of pi is going to be negative 1, so this is negative 1 and just 1. And then cosine of 0 is positive 1, so minus negative 1 would be plus 1. So we get 1 plus 1, which is 2. Number 5. Okay, so here we've got a function in the numerator, and we want to find the derivative here. So this is where we're really going to dig into that first part of the fundamental theorem of calculus, which we covered in this lesson. If you're a little confused about what I'm about to do, just go back and review the lesson video, and I think it'll make sense. But basically, we want to find the derivative of this. Let's not leave out the dt there. We want to find the derivative of this expression. And so to do that, and maybe I'll just write it out. So f prime of x is going to equal, first we need to substitute this guy into t. Okay, so the square root of sine x. And then we're going to multiply that by the derivative of sine x, which is cosine x. And so there you go. Nothing more to do there. Let me move this little arrow here so it's a little cleaned up, but yeah, there's number 5. Number 6. It's a very similar problem here. In fact, we're going to do basically exactly the same thing. Might need to be a little bit more careful with our differentiation on the second part of it. Let's just discuss it as we go. First, we'll substitute in x squared here. And so that would be, let's see here, sine of x squared cubed, which would be x to the 6th. And then we're going to multiply by the derivative of x squared, which would be 2x. And yep, that's it. Number 7. Looks like here we've got a table with values for f, f prime, g, and g prime. Part A says if h is the composition of f and g minus 6, determine h of 3 and h prime of 3. So let's start with h of 3. So h3 would be f of g of 3 minus 6. So we'll evaluate that composite function from the inside out. G of 3 is given right here as 4. So this is going to be f of 4 minus 6. And then f of 4 is given as negative 1. So negative 1 minus 6 is negative 7. So h of 3 equals negative 7. Now to find h prime, we're going to have to differentiate the expression for h, this one right here. So if that's h, then h prime, and I'll just find h prime before actually substituting 3. I'm going to have to use the chain rule. So I'll have f prime g, okay, the derivative of the outside with the inside staying the same, times the derivative of the inside, so that'd be g prime. The derivative of 6 or negative 6 is just 0, so I can safely ignore that. And now I can find h prime 3, which is going to be f prime g of 3, f prime of g of 3 times g prime of 3. Now, g of 3, we can see from the table is, let me just erase all this. Actually, we already evaluated g of 3. Don't need to erase that because it's going to be 4. So this will be f prime of 4 times g prime of 3, right here is 2. So lastly, we need to find f prime of 4, which we can see right here is 3. We get 3 times 2, which is 6. So h prime of 3 equals 6. For part B, it says if W is defined, as we see it, find W prime of 3. So we're going to differentiate that expression and then substitute in 3. So first, let's just differentiate it. To do that, we're going to substitute g of x in for t here. So let me write it out. The derivative of the integral from 1 to gx of f of t dt is equal to f of g of x times the derivative of g of x. Look at that. Now, this is something that we already found. I think, oh, no, maybe we didn't. Yeah, no, we didn't. So let's go ahead and just work this out. So we want to find, so that is w, actually. This actually is going to be our w of x. Oh, sorry, w prime. And then so w prime of 3 will be f of g of 3 times g prime of 3. G of 3 is 4. See that right here. And then g prime of 3 is 2. So we need to find f of 4, which is negative 1, times 2 is negative 2. So w prime, the derivative, or the instantaneous rate of change of function w when x is 3, is negative 2. And there's number 7. Okay, number 8. It says if f of x equals this integral, then what's f prime of 2? So we are going to need to differentiate. So let's first find f prime x. That's going to be 1 over 1 plus the natural log of x cubed. Notice I just took that upper bound and plugged it into t, times the derivative of that upper bound, which is 3x squared. So if I want to find f prime of 2, that's going to be 1 over 1 plus the natural log of 2 cubed is 8, times, let's see here, 3 times 2 squared is 4, so that's times 12. So f prime of 2 should be 12 over 1 plus the natural log of 8, and I do see that as choice D. Number 9 gives us the graph of a piecewise linear function. The graph of a piecewise linear function shown in the figure below. If g of x is equal to that integral, which of the following values is greatest? Okay, so let's see if we may just have to evaluate each one of these. Let's see what happens. Okay, so if g of x is, let's figure out what g of x is here. So when you integrate this, well, maybe I'll hold off here for a second. Let's see what let's start with g of negative 3. So that'll be the integral from negative 2 to negative 3 of f of t. So here we're really just looking for the area under the curve from negative 2 to negative 3. Now those boundaries are backwards, so just to be careful, this is the opposite of the integral from negative 3 to negative 2 of ft. So let's find that area. It looks like we have a trapezoid. So that's going to be, and I'm going to carry this negative along with it, this one right here, negative, and then let's find that area. So it's going to be the base is 1, and then the height is going to be the average of those two heights, which is going to be 1 and 2, so it's going to be 1.5. So the area here is going to be negative 1.5. Okay, so let's take a look at g of negative 2. So g of negative 2, if I put negative 2 right up here, well, that's just going to be 0 because the upper and lower bound are going to be the same. If I find g of 0, that's going to be the area under the curve between negative 2, which is here, and 0, which is here. This is another trapezoid. Okay, so that's going to have a base of 2. The average height here is going to be 1.5. So we have 2 times 1.5, which is 3. G of 1, okay, will be the area between, well, let me actually label that since we know what that is now. So we know this is 3 from here to here. And if I'm going to go from 0 to 1 now, I'm going to add on the area of this little triangle there, which is a 1 by 2 triangle. So 1 times 2 is 2, and half of that's 1. So this would be the 3 plus the 1 is going to be 4. And I guess I could fill this in too, just to kind of get it all out there. And then finally, the last one is G of 2. So that's going to be the area from negative 2 here to positive 2 here. So just be careful because we are dealing with a signed area. The area underneath this curve will be negative. It's a 1 by 2 triangle again, so the area is just going to be 1. So if the area here is 1, we're going to have the value of that integral be negative 1. So if I'm going from negative 2 right here to positive 2, I need to add up those three numbers, 3 plus 1 plus negative 1. Now the 1 and negative 1 will cancel out and give me 3. So that means this is going to equal 3. I'm looking for the value that's the greatest. And yeah, it looks like it's going to be choice D because that's 4 and that's bigger than everything else. Number 10, if f is the function given by this integral, then differentiate it and evaluate it at 2. Okay, so f prime 2 is going to be, well, let's first figure out what f prime is. F prime is going to be, if I substitute in 2x for t, I'm going to get the square root. So yeah, let's find that f prime x first. Square root of 2x squared minus 2x, and then times the derivative of 2x, which is 2. So if I want f prime of 2, that'll be the square root of, let's see here, 2 times 2 is 4. 4 squared is 16. And then 2 times 2 will be minus 4. And then we have a times 2 on the end. 16 minus 4 is 12. So this will be root 12 times 2. And we see that that is right here, choice E. Now, I noticed that on the answer choices here, the square root is not reduced, but you might want to be prepared just in case that it would be. 12 can be rewritten as 4 times 3, and the square root of 4 is 2. So this could be 2 root 3 times 2, or 4 root 3. We didn't have to do that on this problem, but please come and talk to me if you're not sure how I'm doing that. I can show you real quick. But you do want to be prepared in the event that all the answer choices are in reduced form. Okay, that brings us to our last problem, number 11. It says the height of a tree at time t is given by a twice differentiable function. Basically, the fact that it's twice differentiable just means that the derivative of h is also differentiable, so that the second derivative can exist. It's really sort of a technicality. You don't really usually have to even worry about that on the AP test. Where h is measured in meters and t is measured in years. Selected values of h are given in the table below. Use the data in the table to estimate h prime 6. And then give me the units and interpret the meaning. So to try to find the slope at time 6 is going to be like right here. So the only 2 points that we could reasonably use are going to be 5, 6 and 7, 11. Oh, what's going on there? 7, 11. So I'm going to write those 2 points down, 5, 6, 7, 11. I'm going to use those 2 points to estimate the slope at t equals 6. So I've got 11 minus 6 over 7 minus 5. That's going to be 5 over 2. So 5 over 2 meters per year, okay, because h is measured in meters and t is measured in years. Okay, so we've got the answer. Let me highlight this as we go. This is what the AP test grader is going to be looking for too. We've got the actual numerical answer. We've got the units, but now we need the interpretation. So usually the interpretation has to do with like explaining like what this thing means. So here you don't need to write this word for word, but something along these lines. At t equals 6, the tree is growing. We know it's growing because the rate of change is positive at a rate of 5/2 or 2.5, either one's fine, meters per year. So that's like the full-on explanation. Part B says, use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval, in between 2 and 10. So if we're looking for the average height, that's an average value of the height function. So that's going to be the integral from 2 to 10 of ht dt divided by 10 minus 2. Now, the whole trapezoidal sum, that piece of it, that's what we're going to use to estimate the value of that integral. You still need to divide it by 8 at the end, but we'll use that trapezoidal sum to approximate this value, since we don't actually know what h is. So with this trapezoidal sum, I'm thinking about these points, and we've got 4 intervals. So we've got one interval from 2 to 3, one from 3 to 5, one from 5 to 7, and one from 7 to 10. And we still want to be thinking of them sort of like rectangles where it's base times height. But with the trapezoid, you don't have a consistent height, so you have to use the average of the two heights of the two partitions. So I'm going to do base times height in each case, and let's lay out the bases here. So the base for the first interval is just going to be 1 from 2 to 3. The base of the second interval is going to be 2 from 3 to 5, 2 again from 5 to 7, and then 3 from 7 to 10. So those are the bases. In other words, it's going to be like 1 times something plus 2 times something plus 2 times something plus 3 times something, all those somethings being the average heights of the two partitions that surround the interval. So the first one is going to average 1.5 and 2. So we'll have like 1.5 plus 2 over 2. And for the next one, we're going to average 2 and 6. So 6 plus 2 divided by 2. And then for the third one, we're going to average those two partitions, 6 and 11. So 6 and 11 divided by 2. And then for the last one, we've got 11 and 15. So 11 plus 15 divided by 2. Yeah, I'm not going to even bother trying to simplify this. I'm not going to assume we can use a calculator here. So I'm just going to leave that alone and say that what this whole expression here represents the average height of the tree. So our units are in meters, and that's your answer. Now, if you're just trying to check and make sure that what you got is right, like and maybe you set it up slightly differently, I did go ahead and type that in the calculator just so you would know. It's 8.21875. So if you get something, if you get that, then you know that your setup's good too. Okay, last problem. Use the data in the table to determine the value of the integral of 7 to 3 of h prime t. Using correct units, interpret the meaning of your answer in the context of the problem. So let's use the fundamental theorem, the second part, to set this up. Remember that second part gives us a way to evaluate these definite integrals. And so the antiderivative of h prime is just h. So we're going to evaluate h of t plus c from 3 to 7. So this will be h of 7 minus h of 3. H of 7 being 11, and h of 3 being 2. I'm getting both of those values from the table here. So 11 minus 2 will be 9. Okay, so we want the units and we want to explain the meaning. So 9 represents the number of meters. Okay, so it's 9 meters. That's like sort of the first part of the question. And then the explanation, we can say something like, and again, put this in your own words. It does not have to be word for word. We just want to basically explain what the numbers mean. So the tree grew in height by 9 meters. And this next part is a part that's easy to forget. But because of the nature of these problems, it's important for us to say that that's not to just say that it grew that much, but to be specific about when did it grow that much. Okay, from t equals 3 years to t equals 7 years. And I think you can get away without actually putting years there, but it did specifically say use correct units. So try to be on the safe side there. And that's it for tonight. I hope you enjoyed watching this video. Hopefully you found it helpful. If you have any questions, please reach out, and I'm happy to help you out further. But otherwise, y'all have a great night, and I'll see you next time.